Okay, so we're going to talk about set interval notation. Okay, so there are a few things that you have to know, okay, in order to be comfortable with the questions that can come under set interval notation. Okay, so one of the things, the inequalities. Okay, so we have the inequalities like less than, okay, or we have less than or equal to. Okay, we also have greater than or equal to. And then we have two types of brackets under set interval notation. We have the curved brackets like these ones. Okay, and then here you have some number A, comma B. And then also we have the square brackets like that ones. Okay, so these curved brackets here, okay, are the same as these two inequality symbols that do not have an equal to down there, these curved brackets like that. Okay. And then these ones that are less than or equal to or greater than or equal to. So here I should have written it the other direction. So it should be like this. Okay. So if you have less than or equal to, greater than or equal to, you have to use these squared brackets like that. Okay. So what do they mean? I'll start with the brackets. So if you have curved brackets like this, it actually means the endpoint or the number that is here is not actually part of this set. Okay. Even the number that is there, if you have a curved brackets like that, it's not part of this set. And then if you have square brackets like these ones here, okay, it will mean that the number at the ends here are actually part of this set. Okay, so what do I mean? If, for example, you're given an interval, okay, let's say 2 to 3, okay? So if I ask you how many numbers are in this interval, okay, so some people will say there are only two numbers because they can see 2 and 3. But say, actually, in this interval here, there are so many numbers that you cannot even count them. Okay? So why are there uh, so many numbers in this interval? Because when we're dealing with intervals, we are considering a set of real numbers. Okay, set of real numbers. So a set of real numbers simply meaning we can take any value between 2 and 3 and it still belong to this set. But the actual 2 and the actual 3, they are not even a part of this set. Okay, so we can get 2.1, it will be there. 2.11, it will be there. 2.999, it will be in that set. Okay, 2.71, it will be there. 2.12. Okay, so you can see that between 2 and 3, there is an infinite number of real numbers. There are a lot of numbers, we can't count them. Okay, so what notation do we use to simplify it in math? We just use the curved brackets like that. Okay, so this simply means the 2 is not included, the 3 is not included, but any number between 2 and 3, like these ones that I was writing down here, they will be actually a part of this set. Okay, so from this bracket form, I can also express this, okay, in I can express it in using the inequalities. So here I would say x is a member of this, okay? But what if I want to use inequalities here? They need to be x, okay? Here I'll put the bigger number and then the smaller number. So this one here is the same as this, okay? It's just showing you that x is between 2 and what? 3. But 2 and 3 are not included in this set of x values. Okay, so I can also have x is a member of, I use the same interval. So now, since I've put square brackets here, it means I'm also including the 2 and I'm also including the what? The 3. So the numbers that are in this set, they start at 2. And then I can have 2.1, 2.2, 2.3, whatever numbers up to. The largest number in this set will just be what? 3. Okay, so we have square brackets. It means we include this, we also include this. So I can also express this in inequality form. This will just be the same as, okay, I put x and then less than or equal to, greater than or equal to, put the smaller number here, 2, and then 3. So you see here, we are saying 2 is a part of this because there's less than or equal to. 3 is a part of this because there's less than or equal to there. Okay, so that's what they mean. So now you'll be required to transform these things from the inequality style like we have here, or the bracket style like we have here and there, you'll be required to get this form to put it on the number line. Okay, so how are you going to do it on the number line? Okay, it's very simple. Okay, because I've said what the closed brackets means and then the curved brackets what they mean. Okay, so if I have, for example, let's say x is a member of 2 to 4, and then they tell you to put it on a number line. So you just draw a number line, and then you write your 2 there, and then your 4 somewhere there. Okay, and then now you consider the type of brackets that you have. Here I have a square bracket, square bracket. So it means at 2, this 2 is included, right? So I'll draw a 0 there, and then I'm going to shade this 0 here to show that even this 2 is a part of this set. And then I'm going to draw a line all the way up to 4. I'm also going to shade this 4 like that. So this simply means this is the interval from 2 to what? To 4. Okay? And then what about if my interval was x is a member of, and then I say 2, 4. So here you see that we have a mixed. There's a curved, there's a square. So here they mean 2 is not included, but 4 is included. So it means here I'm going to draw an open circle. But that open circle, I'm not going to shade it. So I'll erase the shaded part there, like that. Okay? So it means the 2 is not included, so I draw an open circle just above the 2. And then the 4 is included, so I draw a closed one. Okay, so meaning if I have something like this, 2 to 3, this on the number line just be 2 to 3, and then open circle here, even there open circle. So they can also give you this in inequality form, okay? And you have to show it on the number line like that. Okay, so once you understand the curved brackets, the square brackets, you understand the less than, okay, the greater than, the less than or equal to, the greater than or equal to, then you'll be set. You can answer any question in set interval what? Notation. Okay, so having explained that now, let's try to solve some questions from the tutorial sheet. So we start with question 10. They're saying show each of the following intervals on a real number line. So the first one, A, they have square brackets, 1 and -1 to 1, I mean. So this one on the number line, I'll just say -1. I can put 0 somewhere and then 1. So on 1, I have a square bracket, so I'll shade. And then I'm going to, I'm on -1, I mean I have a square bracket, so I'm going to shade it. And then here on 1, I'm going to shade it as well. Okay, so I've expressed this or shown it on the number line. B, so if you have any questions, please ask. We have curved brackets like this. So on the number line, this will be what? So I have -4, 0 somewhere, and my 1. So at -4, I have a curved. So I'm going to draw an open circle. And then I'm going to go there. Even on 1, I'll draw an open circle like that. Okay, why? Because I have a curved bracket. Okay, what about C? Okay, so C, we're seeing some symbol there, some weird symbol. So this symbol here is called infinity. And this one specifically, it's positive infinity. And then the one that has a minus, we're going to be calling it as minus infinity. So on C, I have -1 all the way to positive infinity. So this on the number line, how are we going to show it? Okay, so I'm going to draw a number line here. And I'm going to say this is my -1. This is my 0. Okay, and then this thing goes all the way to infinity. So infinity, I'll put it there. So it means this interval at -1, it has an open circle. And then it goes all the way to infinity. It also has an open circle, like that. Okay, so I hope you are noticing how we are doing these intervals. And then the last one, we have D minus infinity to 0 squared bracket. So here, my minus infinity is somewhere there. Okay, I can say my 0 is somewhere there. So at minus infinity, the circle is always open. Even at positive infinity, the circle is always open. Never shade the circle that is at minus infinity or positive infinity. And then we're going all the way to 0. But look at 0. We have a square bracket, right? So we're going to shade this part here. like that. Okay, so we have shown this on the number line. Okay, so any questions there? Okay, if there are no questions, let's look at question number 11. So question number 11, okay, will just be converting these intervals that we've been given into a set builder notation. So a set builder notation requires us to use inequalities. Okay, so remember the inequalities that we talked about: less than or equal to, greater than or equal to. So we're just going to be using this depending on the brackets that we have. Okay, so this one here and here, you have less than or greater than. If you have squared brackets like that, okay, you have less than or equal to, greater than or equal to. So this is what we are going to be doing here. But we know how to convert something to set builder notation, right? Because we did this on question 1. Okay, we are just putting it in a descriptive form. So we are putting this set A in a descriptive form. So to put this, okay, A, we're going to say set A is equals to a set of all x's such that x is a real number and it's between minus 10 and what? 10. So I'm going to write it like this. It will be a set of all x's such that the x here, okay, because I'm considering this as a set of x's, the x is between minus 10, okay, I'll put x and then 10, and then this x is actually a real number. Okay, so for intervals, it's only real numbers. Okay, and then what signs are we going to put here and here? What inequality signs are we going to put? So for this minus 10, we have what? A curved. So a curved, we said it's this guy. Okay. And then here, no, 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 no. I put it on the wrong place. It should be there. So because this 10 is not included there. Okay. And then this other 10 here, this was minus 10. This positive 10 now is included because I can see square brackets. So I'm going to put it like that. Okay. So when writing intervals, guys, these inequalities should always face this direction. Okay. Never, when you're writing an interval like this, never say something like 10 and then you have the x and then like that. No, this one here is very wrong, does not exist. These signs should always point, I mean, should always open to your right side. Okay, should always open to your right side. So this simply means that x is between minus 10 and 10 inclusive. So the 10 is there, but the minus 10 is not there, according to the interval there. Okay, what about B? Let's look at B. So if you have any questions, please ask. So B, look at what we have. We have square bracket, square bracket. Okay, so it means B will be a set of all the x's such that, and then I put 4, and then x, and then 9, where x is a real number. Okay, so now when you look at these brackets here, it means here I'll put that symbol, even there, put that symbol. So this here simply means x is greater than or equals to 4, but this x is less than or equal to 9. So it's between 4 and what? 9. Okay? And we're putting greater than or equal to, less than or equal to, because we have square brackets. What about C? So C, look at it here. We have a square bracket at the beginning and then a curved one at the end. Okay, so we're going to say C is a set of all the x's such that minus 1, x, and then I put 5, but this x is always a real number. Okay, so here the minus 1 is included, so I'll put x is greater than or equal to 1, but the 5 is not, so x should be less than 5, like that. So that's how we can turn this interval into set builder notation. Okay, let's look at D, the last one. So on D, we notice that on 0, we have a square bracket, and then at the end, we have infinity. So we have a curved one. So D will be a set of all the x's such that 0, x, infinity, but this x is a real number. So it can take any value. Okay, so here is a square bracket. So it means x should be greater than or equal to 0. Okay. Here it's a curved bracket. So it means x should be less than what? Infinity. Okay, so any questions there on what we've done? Okay, so uh, this knowledge is very important, okay, because it's the one that will make you solve any questions on set interval notation. Okay, so here we're just playing with the notation, but we can now try to solve a question. Okay, if there are no questions, proceed. So let's look at question 12. So question 12, it's an actual exam question. So they can bring something in the exam or the test or the quiz that you're writing on Wednesday. So here, let's read the question and understand it. So they're saying, given that the universal set is the interval from -20 to 20 inclusive, and A is from -1 to 20, but the -1 is not included, the 20 is included. B is from -7 to 9, inclusive, all of them. And then C, look at C. C is the union of two intervals. We have the one from -20 to 1, inclusive, and then we're saying union, okay? The interval from 8 to 14, and then that interval is not inclusive. Okay, so find the following sets and display them on the number line. Okay, so the way they ask this question, they're saying find the following sets and display them on the number line. Okay, but to answer this question, you're actually going to do the opposite of what they're saying. You're going to display them on the number line and then you find the sets. Okay, so that's how we find these questions. So on A, they're telling us to find C complement. Okay, so remember, a complement is defined as all the elements that are not in that set. Okay, all the elements that are not in that set, they will compose of the complement. So if they want us to find the C complement, they are just finding all the elements that are not in C. Okay, but what is our C? So we'll first draw the number line. Okay, what's happening? The number line like that. And then we plot the universal set. So now look at the universal set carefully. They're saying it's from -20 to 20. And the -20 and 20 are inclusive because I have square brackets there. So it means here I'm going to shade at the end. And then I'm going to say this is my -20. At the end here, I'm also going to shade. And this will be my 20. So whatever will be happening in this interval here because that's the universal set. Okay, so we have plotted the universal set. And then we're trying to find C complement. So to find C complement, we first have to plot the set C, okay? And then take a look at its complement. So C, okay, let's notice what it has. It has -20 to 1, 8 to 14. So I can say this is my 1, 8, and then my 14 somewhere there. Okay, so let's plot the first part here, the -20 to 1. So the -20 to 1 is this part here. Okay, so the -20 is included. Even the 1 is included. So this is the first part of C. So they're saying this part from -20 to 1, union, okay? The part from 8 to 14. But the 8 and the 14 are not included. So even this one is C. Okay, so where on the universal set do we see that we do not have a C? It's between 1 and 8. Here, we do not have a C. And between 14 and 20, we do not have a C. Okay, because the C is from 8 to 14 -20 to 1. So how then do we find the complement? Okay, we come at this end point of C. Okay, we come at this end point of C. So I'm going to give a very simple example. If you are inside your boarding house, okay, it means you're not outside your boarding house, right? You are inside. So if someone wants you, they have to enter that like inside your boarding house, right? Okay, to find you. So you are inside. And then if you're outside, it means they won't find you inside, right? Okay, so that's the logic that we are going to use here. So if this one here is in the set C, because we have shaded it in the set C, what does it mean? Will it be in the complement? No, because it's in the set C. So just above here, I'm going to draw an open circle like that. okay, to indicate that in the C complement, this one won't be there because it's in the C. And then I'm going to draw a line to reach this end point here, okay? Okay, so here now at this 8, we also ask ourselves, this 8, is it in C? It's not in C, okay? So if it's not in C, then it has to be in the complement. So I'm going to shade this part on top on the 8 here. So this one from 1 to 8, where 1 is not included, but the 8 is included, it's just the C complement. Okay. But that's not the only part for C complement. We also have this part here. So we come at this endpoint of C again. This 14 is not included. So it will be included in the C complement. And then I go to the end. I check my 20 is included. Okay. So is my 20 included in the C? No. Okay, because the green line is not even reaching here. So it means even this part here will be included in the C complement. So this is my second part of the C complement. So you've seen that we have first displayed this set on the number line. Okay, and then now we can write it. So I'm going to say C complement is actually equals to this first interval. Okay, to be 1 to 8. Okay, so here I'm using curved because it's open, closed because it's I mean square bracket because it's closed. And then I'm going to say union. Here on the 14, it's included, so it will be 14, comma, on the 20, it's included. So this is our set C complement. Okay, so any questions there? Okay, any questions there, guys? Any questions? All right, so if there are no questions, let's look at B. So maintain the universal set there. I'll just erase the other part. Okay, so the universal set is there. And then now we're trying to find A complement intersection B. This one here. Okay, so we just have to plot A complement and see where it overlaps with B. So let's start with plotting A. So A is from -1 to 20. So I have -1, okay, to 20, this one here. So this whole thing here will be set A. So at -1, I have an open circle because here I have a curved. And then this is going all the way to 20. So this one will also be shaded like that. So this part here is my A. Okay. And then notice that in the question we have A complement, right? So we have to plot A complement. So if from -1 to 20, it's all A. So it means starting at this point, I'm going to shade it going this side up to -20. This is actually my A complement. Okay. Right. So we have our A complement. So let's see where the A complement intersects with the B. So the B is from -5, -7 to 9 inclusive. So -7 is somewhere between -20 and -1. So I can put it there. That is my -7. And then -9 should be somewhere there. Okay, between the -1 and 20. All right, so you don't have to plot all the numbers here, just plot the important ones. So let's plot the B. So the B is from -7. I'm going to shade it. Let me draw it in black. -7 here, I'm going to shade it because it's included, this one here, all the way to 9. Okay, so now how do we find the intersection here? We just look at the point where the red line of the A complement, okay, will be overlapping with the black line of the B. So this is the B here. Okay. So where are these lines that like they are on top of each other, like that? So I have this one in red, and then on top of this red, I can see a black one. So what is that part? So it is this part here that I'm shading up to there. So it starts at -7 here, it ends at 1. So that will be our set. So A intersection B will actually be equals to. So at 7, you ask yourself, is the 7 in B? Yes, it's shaded. And then is is the okay, is the 7 in B? Yes, it's shaded. Is the 7 in A complement? Yes, because I have a solid line passing there. So it means here you have a square bracket and you put what? -7. You come on this point where it's the intersection is ending. So here in the black line, it's there because it's along the solid line. Even there it's shaded. So it will be comma -1 like that. So that will be our set A complement intersection B. Okay, so any questions there? Okay, so if there are no questions, let's look at C. Okay, so I hope you have ideas now on how to go about these things if you didn't. Okay, so let's look at C. So C involves the three sets. Okay, so I said whenever I see A minus B or any set minus any set, it's the same as A intersection the complement like that. Okay, so A minus B is the same as A intersection B complement. So this guy here is the same as A intersection B complement inside the brackets there, and then I have intersection C. Okay, so here we just want to see where the A, the B complement, and the C are intersecting. Okay, so let's plot these guys here. So this one is -20. Should maintain the blue. Okay, let's plot the A. The A is -1, which will be somewhere there to 20. So I'll plot it 0 all the way up to 20. This is my A. Okay, what about my C? C is this union here. So it's -20, 1. Okay, so 1 can be somewhere there. And then 8 to 14. Okay, so I can put my 1 here, then 8, and then 14. So you just plot the important numbers. So to be what? To be -20 to 1. So shade -20 all the way up to 1. Shade. This is the first part of my C. And then my other one is open at 8, open at 14. This is my other part of C. So we've plotted the set A and the set C. And then we wanted to see where all these three lines, the green ones, the blue ones, and the one that I'm going to use for B complement are going to be overlapping. So to find B complement, we first have to plot B. So B is from -7, which can be somewhere here, to 9, which is between there. So I'll say my B, I'll plot it in red. It will be from here, shaded, all the way up to 9 here, shaded. Okay, so this is my B. So it means my B complement will have two parts, right? We have the part that starts from here going to the right, and the part that starts from here going to the right. So let's plot the B complement with a black marker. Okay, so I'll just plot it down here instead of on top. Okay, so I'll say B complement, since the -7, this is -7. Since the -7 is in the B, then it should not be in the B complement. And then I go here, the -20 will be there. Okay, so this is my first part of B complement. And then my other one will start here. Okay, so I'm writing it down there. So I'll say, since the 9 is in the B, okay, it should not be there in the what? The B complement. And then it goes all the way up to here. I'm going to shade. So this is my second part of the B complement. So now we are looking at where A intersection B complement intersection C. So I'm looking for a part where I have three lines overlapping. We have the line for the C. Okay, why did I write C complement there? The line for the C, which is green, overlapping with the line in blue, which is for the what? For the A, okay? And then should also have the line in black, which is for the B complement. So where can we see that happening? Okay, I can see it here. So starting at here, you can see that the green, the blue, and the black are overlapping there. Okay, and then here, can we see anywhere where the blue, black, green are overlapping? No. So here there won't be any intersection. So the intersection will just be this side. So the intersection is from this number here, which is 9, okay? And then this number here, which is what? 14. That's where the intersection is. So I'm going to say A minus B intersection C, which is the same as A intersection B complement intersection C is equals to, okay? So it starts at 9. It cuts at 14. So what type of brackets are we going to put here? Okay, so you look at the end point. The end point is 9. Okay, so I ask myself, is it there in the green? Yes, because it's a solid line. Is it there in the blue? Yes, because it's a solid line. Is it there in the black? No, because there's an open circle. So I'll put the curved bracket. I come at the end point of 14. Is it there in the C? No. Okay, so if it's not there in one, then it will just be a curved bracket like that. So this here is our A minus B intersection C. Okay, so any questions there? Okay, so if there are no questions, I'm going to end here, okay? But I'm going to upload uh, the other videos for question 13 and 14, which is also sent interval. I'm going to upload them on the website, okay? So I've taught you the concept. You can start practicing because there'll be a question on this in the quiz, okay? And then once you do that, then you are good to go on set intervals. Okay, so now let's look at question 13. We're still on set interval notation, okay? Right, so they're saying let R be the universal set, okay? So if R is the universal set, then it comes from minus infinity all the way to positive infinity. Okay, and then set A be given as this, set B, and then set C has been given as a set builder notation. So meaning we have to interpret it and turn it into an interval. So here they're saying set C is a set of all the x's such that x is greater than 4 and is x is greater than 4 and x is a member of real numbers. Okay, so how can we write this in set interval notation? So it will just be C is equals to, okay, so there will be 4 here. So it's greater than 4. So it's going all the way to positive infinity. And then you have a curved bracket like that. So why are we putting a curved here? It's because here they just said greater than. So x should be greater than 4, okay? But definitely should be less than positive infinity. So this is my C, A, B. So to answer this, okay, first of all, you draw the universal set. The universal set is from minus infinity all the way to positive infinity. So we're not including positive infinity, we're not including minus infinity. Okay, and then we'll be working here. So the first question, they're saying A minus C. Okay, so I've said a number of times, A minus C is the same as A intersection C complement. Okay, so let's plot first of all A. A is from minus 1 to 6. Okay, so there is an open bracket on minus 1 and then a closed one on 6. So this is what we have here. Okay, so this is my A. Then where is my C complement? So to find the C complement, we first plot the C. So the C is this one here, 4 to positive infinity. So 4 can be somewhere there. So I'm starting at 4, open because there's a curved. I'm going all the way to positive infinity here. And then I put open as well. Okay, and then from there, what can we do? Okay, from here, we can now find our C complement. So C complement will be the set that will be starting at here and then going all the way to minus infinity. So we ask ourselves, is 4 in the C? Okay, remember this is the C. Is 4 in the C? No. So it means we are going to shade it in the C complement. And then we go all the way to what? this guy here, which is minus infinity. So minus infinity is never included. Okay, so this is my C complement. Okay, and then here I'm finding A intersection C complement. So I'm looking at a point where the line for the C complement is above the line for the A. So we see that that area is this guy here, starting at this -1, okay, going all the way up to 4. So it means my A minus C, which is just the same as A intersection C complement, will be equals to, okay, I come at here -1. So is the -1 in A? No, because we had an open circle. So here I have curved bracket, -1, comma, and then at 4, okay, I see that the 4 is in A because there's a solid line that is passing at A. I'm using this blue line for the A. Okay, so it's in A. Is it in C complement? Yes, because I can see a shaded circle. So it will be 4 square bracket like that. Okay, so that's our A minus C, or A intersection C complement. Okay, so we're done with A. Let's look at B. So at B, it's the same issue, guys. First of all, draw your universal set. You're not including this, and also not including that. So that is our universal. Okay, and then let's take a look at what we've been given. What we've been given there is B complement intersection C and then complement. So we just want the part, we are looking for the complement of B complement intersection C. So first of all, let's find B complement intersection C. So B, okay, B, it's from 0 to 4. This is my B, and it has curved. So it will be open circle, open circle. So this is my B. Okay, and then where will be my B complement? So my B complement, I come at the end point of B. Okay, so this 0 is not in B, so it will be in B complement. And then I shade all the way to minus infinity, like that. So this will be B complement. I come at the end point here at 4. The 4 is not in B, so it will be in the what? B complement. And then I go all the way to positive infinity, but positive infinity is never included in any set. So these are the two parts for the B complement, right? We're okay with that. Let's plot C in red. C is from 4 to positive infinity. Okay, but the 4 is not included there. So it's starting at here, going all the way to positive infinity. This is my C. Okay, so we're just considering, first of all, what is inside the bracket. We're not considering this complement, okay, as at yet. So what we're going to do here is that we're going to find our B complement intersection C. So our B complement intersection C will just be this part here. Okay, where the red line is above the green line. Okay, here we don't have any red line, so we forget about this. So this part here, okay, so all right, B complement intersection C, it's from 4 all the way to positive infinity, like that. Okay, so why are we putting a curved one here? It's because in B complement it's there quite all right, shaded here, but in C it's not there. So okay, it's not in the intersection. So now we want to find the complement of this. So where can you see the complement of this? Okay, where can you see the complement of this? Just starting at this point here, going all the way to what? Minus infinity. That's the complement. Okay, that's the complement. So B complement intersection C complement will just be equals to from minus infinity all the way to what? All the way to 4. But this 4 now will be included in the complement because it's not here. So it will be included in the complement. So this is our B complement intersection C. But if you wanted, you'd solve this in a different way. So I'm going to show you the different way. So the different way is that we're first going to simplify the set that we've been given. Okay? So we have B complement intersection C complement. We can distribute this complement. Complement to the B complement, I get B. The complements cancel. Complement to the intersection becomes a union. And then complement to the C, okay? It becomes C complement. Okay, so now if you draw your universal set, these are not included, okay? My C is from is from 4 all the way to positive infinity, right? Okay, and then it means my C complement will start here, okay, and then to go all the way to minus infinity. So this is my C complement. So I want to unionize this part here with the B. But what is the B? The B is from 0 to 4. Okay, 0 to 4. So 0 can be somewhere there. So my B will just be from here all the way to 4, like that. So union, it means we are getting everything. We are not getting what is common. If it was getting what is common, we would just have gotten this part. Okay, but we're not getting what is common. We're getting everything. So wherever I can see C complement and B, I'm going to get. So it's starting from minus infinity all the way to what? To 4. And it's the same answer that we got. So minus infinity all the way to what? 4, but the 4 is included because we are getting a union. No wonder we're including it here. Okay, it's just in the C complement. In the B here, it's not there, but we're getting a union, so we also include it. Okay, so you can solve it in this way or the other way in which we did it. Okay, so that is that. Okay, so I'm going to leave C here for your practice. You can try to solve it and then send me the solutions, okay? And then if you are wrong, I'm going to tell you. So C, remember, was this. So let's solve D. So here I have minus infinity, which is not included, positive infinity, which is included. I mean, which is not included. So we are finding A union B complement. Okay, so A union B complement is the same as A complement intersection B complement. Okay, but which one is easier? I think this one is easier, so we'll use it. So A is from minus 1 to 6. Okay, so the minus 1 is not included, but the 6 is. Okay, this is my A. What about my B? My B is from 0 to 4. So 4 can be somewhere here. So this is 0 to 4, not included, not included. So this is my B. So what is my A union B? A union B, remember, we're getting everything in A, everything in B, but not repeating anything. So it means this whole set here from minus 1 to 6, that's the union, because B is just within the A. Okay, it's just within the A. So it means my A union B is actually just the set A. Okay, and then from here now, we find the complement of this. So the complement of this union will be what? Okay, will be starting from here. So the 6 is in the A union B, so it won't be in the complement. So this will be A union B complement, the first part. The other one will start here. So the minus 1 is not in the A union B, so it should be in their complement. So I shade there, and then I go here. So A union B complement. This will be the second part. So now to write the answer, we're going to unionize those things. We're going to say A union B. Okay, A union B is the same as, we start with this one, minus infinity, all the way to minus 1. This is not included, but the minus 1 is included because it's shaded there. And then I say union. Here, the 6 is not included, and the positive infinity is not included. So this is our answer here. Okay, so that's our answer there. All right, so we're done with question 13. We look at question 14. Okay, we're still looking at set interval notation. So here they're saying, let the set J be minus 4 to 14, K 0 to 18, L 10 to 24. Okay, and then they're also saying, also let R the set of all real numbers to be the universal set. So it means my universal set starts from minus infinity all the way to positive what? Infinity. Okay, write down the following sets and represent them on the number line. So we are going to do the opposite. We're going to represent them on the number line and then write them down. Okay, because there's no way we can write them down without the number line. Okay, we start the first one. A complement intersection. A intersection C complement. Okay, it's like we are solving the same questions now. Okay, so that is my universal set. My A is what now? Okay, so I think here they messed up the labeling because here they're saying J, K, L. So I'm sure this is supposed to be A, this is my B, then this is my C. Okay, otherwise they were supposed to put these in terms of J, K, and L. Okay, but we'll put them as A, B, C there. All right, so we're finding A intersection C complement. So A is minus 4 to 14. Okay, and you can see we have square bracket, square bracket. So shade, shade, A. Okay, what about C complement? So for us to get C complement, we first have to plot C. So C is coming from 10 to 24. Okay, so the 10 is included, but the 24 is not. So this is my C. So from here, since I've plotted my C, I can now plot my C complement. So I start at the end point. The 10 is in the C, so it won't be in the complement. And then I go all the way to minus infinity. So this is the first part of C complement. The other one will start here. So the 24 is not in the C, so it will be in the C complement. Then it goes all the way to positive infinity, second part of C complement. So now, we are finding the intersection of A and C complement. So the A is the one in this blue line here. The C complement is this one in red. So where can we see an overlap of the A and the C complement? You can see it from here, this part here, up to here. Okay, so my A intersection C complement will be equals to, I come at the end point here, which is minus 4. Minus 4 is included in the A because it's shaded, and it's also included in the C because there's a solid line passing at minus 4. So here I have square bracket minus 4, comma. Here at 10, the 10 is in the A because there's a solid line passing at 10 here. Okay, but is it in the C complement? The C complement there I can see an open circle, so it's not. So this would be 10 curved brackets. Okay, so this is our answer here on A. Okay, as simple as that. All right, let's look at something that is hard. Okay, because B is just the same thing as we have been doing. Okay, so B, remember we have B minus A. So I said whenever you see subtraction of two sets, okay, you just write the first set intersection the complement of the second set. So this will be A complement. Okay, so can you fail to find this? No. You first have to find the A complement, intersect it with the B. Okay? Or maybe let's just do it. Okay. Not wait, tutaposa na solve. Let's do it. So B, okay, B, we're coming from 0 to 18. Okay, this B here. And 0 is not included. Even the 18 is not included. So this is my B. And then now I have to get my A complement. So to get the A complement, you first have to draw the A. So A is from minus 4 to 14. So 14 is somewhere here. Minus 4 is somewhere here. So the minus 4 is included. Okay, even the 14 is included. So this is my A, but I'm not interested in the A. Okay, I'm just drawing it here so that I can get my A complement. So A complement at this point here, okay, means the 14 won't be in the A complement. It goes all the way there. First part of A complement. The second part will be here. So at minus 4, the minus 4 is in the A, so it's not in the A complement. And then I go to minus infinity, second part of A complement. So now, where can we see the intersection between the green line of the B and the red line of the A complement. Okay, we can see that the intersection starts at this point here. Okay, so it means A, or rather B minus A, which is the same as B intersection A complement, will be equals to, okay, starting at 14, ending at 18. But now what type of brackets do we put here? So we come at 14. So in the green line of the B, 14 is there because we have a solid line passing at 14. Okay, but in the A complement, there's an open circle. So we have curved. At 18, in the B, I have an open circle. Okay, so it will also be curved. So this one is my B minus A. Okay, that's my B minus A. Okay, and then from there, let's look at C. Okay, let's look at C. Okay, so C, we have A intersection B union C complement. Okay, so we just have to plot this part and then intersect it with A. Okay, so let's plot B union C complement. So B, okay, remember we are taking this as our A, this is our B, and then this is our C. So our B is from 0 to 18. Okay, not included, not included. This is my B. What about my C? Okay, what about my C? So C, okay, here we want the C complement. So we first plot the C. So C is from 10 to 24. Okay, and the 10 is included, the 24 is not. So this is my C. So we have to find now the complement. Okay, so complement, when you come at 24, the 24 will be in the complement. C complement, first part. The 10 won't be in the complement. C complement, second part. Okay, so now we're trying to unionize. Okay, we're trying to unionize the C complement with the B. Okay, so now take follow the story very nicely. Okay, we are taking the union here. So most students make a mistake here. Okay, we are taking the union of C complement with the B. Okay, C complement with the B. So it means wherever there's C complement, I need to get those values. Wherever there's B, I need to get those values. Okay, we're not taking the intersection. So the C complement is from 0 to 10. The B is from 0. The C complement is from minus infinity to 10. The B is from 0 to 18. Okay, so if I unionize this first part here, it will just be from minus infinity all the way to 18 because I'm taking the union. Okay, so that will be the first part. And then we see a discontinuity here. Okay, and then I'm going to unionize it with this other C complement, which is 24 to what? Positive infinity. So B union C complement will be, the first part will be from minus infinity, comma, all the way to what? To 18. Okay, but this 18 is not included there. So I'm going to write 18 curved. Okay, and then union, this other part of the C complement. Okay, remember the B, it's within here. Okay, when you unionize it, the B is within here. And then union, this part, to start at 24, included all the way to positive infinity like that. So this here is my what? My B union C complement. And then I want to intersect this part with the A. Okay, so these first lines I drew were used to find this. Okay, so now let's plot the A. Okay, so since we found the B union C, I can just write it now here that it starts from here all the way to 18. Okay, and then it starts at 24 all the way to positive infinity. So now I want to unionize this part that I've drawn here with the A. But the A is from minus 4, which will be somewhere here, to 14, which will be somewhere here. So to be shade there, shade there. Okay, so where can we see the intersection? It's just this part here. So it means this set will just be equals to the things that are common are just the set A itself. Okay, because we can see the set A is just within this B union C complement. Okay, so the answer is just set A there. Okay, so sometimes these questions come like write this, okay, in simple notation. So those were the questions we are answering like on question 7, 8, 9. Okay, those videos are there on the website. You can watch. Okay, and then what else now? Okay, let's try to find D and then F, and then we'll be done. Okay. Okay, so D, we first have to simplify this thing before we can sketch it. So we have this A complement minus B minus C complement and then complement. Okay, so let's distribute this complement here. So if this complement, okay, so before that, we have to remove this to my minus sign inside there. Okay, so remember, I said A minus B. It's the same as A intersection B what complement. Okay, so inside the brackets there, okay, take a look at what I'm going to do. So this is A complement, okay, and then since I have a minus here, I can use this rule. So it will be intersection B minus C complement and then complement. Okay, and then I have the one which is outside, which is complement. Okay, I don't know if you've seen what I've done. If I have A minus B, right? This is the same as A intersection B complement. Okay, so here now I have A complement minus C, B minus C complement. So this one here is acting like my B, this whole thing, and then this one here is acting like my A. This is like my A, this is like my B. So A minus B is the same as A intersection B complement, right? So whatever is inside here is like A, I mean it's like B, and then whatever is here it's like A. So no wonder I get that. Okay. And then I have this complement, which was I have this complement which is outside, which is this. So it goes with it. Okay. So don't confuse the complements there. And then I have this complement that has come here because of this minus. Okay. And then these whole things are in the brackets with the complement outside. Okay. And then from there, let's deal with this guy. So we have A complement intersection. Here, inside the brackets, it will be B intersection C complement. Okay. And then I have the complement outside. Okay, now we're dealing with too many complements, and then complement, and then complement. Okay, I hope you're following. If you're not following, just pause the video, repeat it again. Okay, and then from here, we can see that this complement, okay, actually we can start with this one. Okay, we can start with any anyway. So it will be a complement intersection, okay? This complement, we distribute it to where now? Okay, okay, first let's write this complement. And then now this complement outside, we distribute it to whatever we have in these brackets. So complement and complement, they cancel, right? So it will just remain the way it is. And then C. Okay. And then from there, which one should we distribute? Okay. Which one should we distribute? So here we can distribute this guy now. So this complement goes to this complement, and then it goes to this whole term here. So it will be complement to the A complement. It will just be A. The complement cancels. Complement to the intersection to be union. And then complement to this, I get B intersection C complement, complement. Okay, so this complement here has come from here. Okay, so I'm still simplifying this. You see that it's complicated. So we have to simplify it. So I have A union. And then now this guy can go inside there. So when it goes to the B, what I have is the B complement. Okay. When it goes to the intersection, this one, what I have is union. When it goes to the C complement, I just have C. So this is what I have here. Okay, so it's like I'm finding A union B complement union C. So this is what we are finding. So we can now plot this on the number line. Okay, so let's do that. So let's start first with this B complement. So positive infinity not included, minus infinity not included. So we're going to say, let's plot the B complement. So the B is from 10 to 24. And, oh, that is the C, right? The B is from 0 to 18. So this is not included. This also is not included. Okay, that's my B. But I'm interested in the B complement. So the B complement will be 0 included, 18 included. And then here it goes all the way to positive infinity. Even here, it goes all the way to positive infinity. Okay, so this is B complement, B complement. So where is this B complement unionizing the A and the C? So let's plot the A. So the A is from minus 4 to 14. So it will be from here all the way to 14. This is my A. Okay. And then where is my C? Okay, where is my C? C is 10 to 24. So 10 will be between 0 and 14. 24 will be after 18. Okay, so here the 10 is included. Okay, and then the 24 is not. So this is my C. Okay, so what is the intersection now of the C, the A? I mean, what is the union of the C, the A, and the B complement? Okay, we see that it's basically everything, right? Okay, because we are combining everything but not repeating anything. So the B complement starts from here and it goes there. And then it also starts from there, it goes there, right? Okay, so the points from 18 to positive infinity and from 0 to minus infinity, they're already included in this union. Okay, what is remaining is just the points between 0 and 18. But the points between 0 and 18 have been included because this A is going from minus 4 to 14. So it has included from 0 all the way to what? To 14. And then this C is from 10 all the way to 24. So it has included these points that the A has left out, which is 14 to 18, this part. So when we actually combine everything here, we see that we get the whole set. Okay, it will be from minus infinity to positive infinity. That will be the union here. So we're going to say minus infinity to positive infinity. That will be our what? Our union. Okay, that will be our union there. Very nice. Okay, because it's covering everything basically. Okay, and then what else now? Okay, we can solve the last one. So the last one, we're going to use De Morgan's laws to be very easy. We solved a similar question on the previous. So A complement intersection B complement, okay? But De Morgan's laws, it's the same as A union B and then complement outside. So when you distribute the complement to this, it becomes A complement. To the union, becomes intersection. To the B, becomes B complement. Okay, and it's the same question that we had here. Okay, but let's plot it before we are accused. Okay, so positive infinity, not included. So I'm using this one to get the answer because it's faster. So A, so minus 4 to 14. This is my A. Okay, and then I'm unionizing this with my B, which is 0 to 18. 0 not included, 18 not included. So what is the union now? So we are getting the union, okay? So we are getting everything from minus 4, where the A starts, to the 18, where the B starts. Okay, but notice that minus 4, we are including it, okay? At 18, we are not including it. So this whole thing here is my A union B. So to find the complement now, I come at the end point. The minus 4 is in the union, so it won't be in their complement. So this will be the first part of A union B complement. Okay. The other one will start at 18. So 18 is not in the union, so it will be in their complement. Then you go to a positive infinity. So this will be the second part of A union B complement. So our answer for A complement intersection B complement will just be what? The union of these two. So it will be from minus infinity all the way to minus 4, union positive 18 all the way to what? Positive infinity. Okay, so this will be the answer. And we are done with questions on set interval notation. Okay, so continue studying for your quiz. Okay, know all the concepts on set theory. Okay, and then yeah, you'll be good like that. Okay, so we've solved the questions on the tutorial sheet from question 1 up to 14. Okay, so I've solved up to here. Okay, so for those who would like to access the full video, okay, from question 1 where I started, okay, I solved all these questions here that you can see. Solved them here from question 1. Here we have ended on question 14. Okay, but there are videos on our website from question 15, 16, 17, 18, 19, 20, 21, 22. So all these questions here, there are videos on our website. Okay, so if you'd like to access them, please, you are free to register. Okay, just follow the link in the description below here. There's also my number. There's the link to our website, the link to our mobile app. So on our mobile app, okay, you are allowed to download the videos. You can even watch them offline in your blankets. Okay, so no risk of moving in the night to go and attend tuitions. No. Okay, we have already catered that for you guys. Just learn even when you are sleeping. Right, so this has been Tutor Post Solutions. Thank you so much, and see you in the next video.